All right. Looks like time. Before we get started, I'd like to introduce myself. My name is Sam Spencer. I'm a program manager on the XAML team at Microsoft. So what I'm going to talk about today is the next evolution we've added in Windows 10 for XAML data binding. So the big thing that's driven kind of requirements into the XAML team for this release is we picked up some large internal clients, specifically Office and the Windows shell. On both those teams, one thing they're really hardcore about is performance. And particularly the Office guys, they came and said, hey, if I set a property through code versus setting it through data binding, then that's orders of magnitude faster. We're like, oh, OK. Let's see if we can fix that for you. And then the shell guys came along and they said, hey, we need to kind of reduce the memory consumption. We need to be back kind of where we were with Splash, but with XAML. So it's like, yeah, OK, let's have a look at that as well. And so what we've come up with for this release is a new version of data binding we're calling compiled binding. And the big difference between this and what you've seen in binding before is the heavy lifting, which is kind of reflection work, is now done at build time rather than at runtime. So with classic binding, it'll create binding objects, binding path objects. At runtime, it has to use reflection or other APIs to go figure out what are those types and to go kind of hook together all the binding. What we do now is we do that at design time. We generate code, it goes into your code behind. That means you can actually go inspect the code, look at it, debug it. There's no magic going on in data binding. It also means we do validation of the bindings. So if you mistype or your object model isn't public or whatever, you'll get a compile error for it at build time. So at the end of this session, what I hope you know is like, what is compiled binding? How do you use it in your applications, the pros and cons, and have a brief understanding of what's kind of going on under the hood. So first thing we'll do is start off with a demo. And slide 8. So this is a micro benchmark application I've written. What this does is demonstrate differences between the bindings. So I've got a series of user controls in here, each of which then has a series of stack panels with effectively a grid of 40 by 40 border elements. And each of those border elements has its background color set with the data binding. So in this case, I'm using classic binding. Actually, let me boost that up a bit. Using classic binding, but I can also do it with xbind. By doing this with a 40-40 grid, we're doing 1,600 elements. It gives us something kind of measurable to track for performance. So if I flip over to the runtime of this, we can see the application in action. So if I do no bindings, we get a time counter here. This is kind of from when I create the user control till the frame is submitted to be rendered. First frame submitted to be rendered. So it's a pretty good time of like, what does it take to do the tree operations and get that page ready. So with no bindings, we're talking about 27 milliseconds. One-time binding, we're looking at 81 milliseconds. It varies a little bit, since we can get a better one, 70, 68. Each time I do it, I'll get a slightly different result. So that's xbind. We're in the 70 millisecond range. Comparing that with classic binding, that's in the 500 millisecond range. So xbind is substantially faster in these kind of micro benchmarks. Those are one-time bindings. If I do one way, we'll see xbind similarly about 70 milliseconds to go create the model. When I hit the change color button, what that does is changes the data model and changes all the colors to random. So that's taking kind of 15 milliseconds. Binding one way, similarly large to create it, and if I change the color, it takes more time. So if I switch back to PowerPoint, what I've got here is a screenshot from a tool we call WPA, Windows Performance Analyzer. Are you guys familiar with this tool at all? OK. It's what we generally use internally to track performance. It's a sample-based profiler, so every millisecond it gathers samples, and that's what we're seeing for the top part of this graph. So this section is for classic binding. This one is for compiled binding. We can see I put in custom ETW markers for kind of the begin and end. So we can compare that. And you can see the CPU is basically pegged at 25% for the entire time. The reason it's at 25%, not 100%, it's a 4-core machine, and therefore it's a UI thread that's just pegging one of those cores. Looking at the second part, the generic events, these are ETW markers that are fired by XAML. Each one is represented as a little diamond, but if you get a whole bunch very close together, that's where you end up with a bar. And so what this is showing is we do a whole bunch of element creation, and then there's a lot of other work that isn't kind of involving the XAML tree. We look at the same thing in compiled binding. Our element creation is smaller, and then the second section is substantially smaller. So what I can do is I can drill in to the call stack to see what's kind of going on with this. And we see during the first part, what we're doing is we're creating our binding objects. That's why it takes more time to create those elements. And then the second part, this whole gap where XAML activity really doesn't seem to be going on, that's where we get the data context change notification, and each of those binding expressions is now being parsed and understood, reflection, what have you, which is why it's taking kind of so much longer. And so with XBind, what we've done is moved that work to compile time rather than runtime. So that was CPU. From a memory standpoint, compile binding, because we don't have to have those binding objects, is also substantially smaller. So we can see here is the example, no bindings. One time with XBind is a little bit higher. Classic binding, substantially higher. XBind one way is a little bit higher than the one time. We're creating the listener objects, and then binding one way is substantially larger than that again. So this was a micro benchmark. It kind of accentuates the differences between binding. But to put this into context of real applications, Start recently moved to XBind. They saw an overall reduction in their heap of 10%, and 18% if you just look at memory that's attributable to XAML. So that's quite a good reduction in memory just by changing your binding expressions. The People app on the phone, they just switched over. They're a C# app. Their startup is down 11%, and their Win32 heap is down 21%, just by changing to XBind. So there's some good performance kind of bona fides there in the technology. So how do I use compile binding? Well, the simplest view is you take your squiggle binding expression and replace it with x:bind. But there's a bit more to it than that. We looked to see, could we convert this technology and use, put that in kind of place of where the binding expression is, the traditional binding is used, continue to use the same expression. The problem is we couldn't do it with, while being backwards compatible, and we need extra typing information that isn't available to traditional binding. So with classic binding, it tends to use the data context or a source property set on the binding object. Both of those are object type, so we don't have the type information we need to go and do code generation. So for XBind, to do the code generation, we need that type information, so it's strongly typed. So for bindings inside a page or user control, we use that page or user control itself as the context for the bindings. The other big change we've made is because we want to be pay-for-play for performance, we've changed the default mode of the binding from being one way to one time. You can still use one way, just need to be explicit and opt into the extra work that's going to go on for that. So let's take a look at what it takes to actually use XBind in your app. I should switch across. Okay. So what I've got here is a very simple application. I've got a page with a text block in it, and in my code behind, I've got two fields. One, a string field called data, and a model field called model. And that model has a bunch of different properties over here. It's the same model that's used in the SDK sample. So to actually use XBind, what I can do is just do x:bind data. If I run it, that's now going to go find that data field, and so I can bind to that. It also means you can bind to fields as well as properties. A very simple kind of instance of data binding. We support all the same expression types pretty much that you can do in classic binding. So I could do dot. So if I do string proc with INPC and now build, what I'm actually getting is a compile error here saying that it can't find string proc with INPC. That's because I misspelt the W, So capitalize that again, build. So that's an instance of the kind of validation we do as part of your compiler is now at build time rather than at runtime. Chance of you running into problems at runtime now, significantly less. What I've got here is a demo app. This is an early drop of the demo that's in the SDK. Those got published today about 2 p.m. So you can go download it. It'll be black. It's got a slightly different menu, but all the rest of it is exactly the same. So what I've got in here is a set of different bindings. So one-time binding, pretty obvious. We'll read the field. We work on fields, properties, dependency properties. If you say it's one time, we don't do any change detection. Kind of works pretty much as you'd expect. One-way binding, I can still try and do a one-way binding against a field or a property that doesn't have INPC on its class. And in those cases, we're not going to get the changes. We'll get the changes if you implement iNotify property changed, or it's a dependency property. So what I have here is a set of fields. As I update the data model, my UI updates respectively. We also support index path bindings. So this is if you want to bind to a particular member of a collection. It's not so much for list scenarios, but like, hey, I want to find the first customer or those kind of scenarios. Then I can use square brackets and integer to index into that particular collection. Let me just do a reset values. Binding to just text box is a little bit boring. I can bind just about any control in any way. So what I have here is some two-way bindings. These are binding to the model. As I adjust this slider, it will adjust the other one that's bound to that same model property. Similarly for this guy, and I've also got like other elements down here that are bound to the same thing. Two-way bindings, pretty much the same syntax you used before. So I have a toggle switch here. It's a Boolean property. And then I'm binding the visibility in this property to that. So if I go to basic test, sorry, wrong file. I want other bindings. So if we go look at this, I have a toggle switch. It's bound to a Boolean property with change notification in our model. You don't need to name it with INPC or whatever. It was just kind of, for demo purposes, named that way. And so binding the visibility, same as you kind of do before. Same problem that the model is a Boolean property. Visibility is an enum type. How do I get a Boolean to an enum? So you need a converter. And so we support exactly the same converters using iValue converter that you'd see with classic binding. So if you're familiar with XAML data binding, there should be nothing here that's kind of really new and revolutionary, just a different squiggle, just a different binding expression at the beginning. Showing some other stuff in this markup. If I want to bind to another element in my page, with classic binding, you would use an element binding and specify the particular element name. With compile binding, because we're using the page or user control as our data context, if you name an element, it has a field generated in there, so you can just bind directly to that element by its field name. So in this case, I can bind to grid 1, just because that's actually a grid on that's named. It gets a field on my page. I can just bind directly to it. So here's an example of using index path property. I've got a local text box. I bind a bunch of other things to that. So for instance, this expression works for C#. Doesn't work for C++ because length isn't a property there. But in this case, when I adjust my hello world text, you'll see the counter down here change along with it. And how that's working is that's bound to the text property of that local text box, and then using the length property. And because the text is a dependency property, that fires a change notification, and that'll cause us to evaluate the rest of the expression as well. So those are kind of simple bindings. We can also bind things like a grid.column attached properties. We can bind two attached properties. So in this case, this is actually a grid with 10 columns defined. And as I adjust the sliders, I'm adjusting the grid.column for those elements. This image has a render transform on it, and so I can bind properties within inside the render transform. Let's go to translate, rotate, and translate. If I just do update values, you'll see that moves. Reset, that moves. We also do target null value and fallback value. Target null value is when the leaf node of your binding expression is null. So in this case, if first name was null, then, and I specified a target null value, that will get used in place for the binding. Fallback value is used when other parts of the binding expression return null. We're a little bit more sensitive to errors than classic binding. You'll get the exception. You can break through, see the code, step through, and figure out what's happened. So we're a little bit more debuggable, I should say, is probably the polite way of putting it. All right, I think that's everything I wanted to show there. Yep. Yeah, switch back over here. So, considerations for data binding using XBind. Data conversion. We will implicitly convert to and from string. So if you're binding a text block, and you want to bind that to an integer field, we'll automatically call toString for you. In the other direction, we have exposed an API to use the XAML parser's logic for string to objects. So for target null value, fallback value, if I'm using those on, say, a background property, which needs to be a brush, then I want to be able to specify a brush, but how do I do that in a string? Well, the parser already supports that. That's how I can say my background is red. So I can similarly use red in the value here for XBind for the fallback value, and we'll use that same parser logic to translate that into a solid color brush for you. Similarly, you can use pound FF, A, B, C, D, E, F, or whatever. The case where you need converters is when you can't do an assignment directly in code. So we can do widening conversions automatically or implicitly. So you're binding an integer to a value on a slider, which is double. That's a widening conversion that happens automatically, but vice versa doesn't. If you want to use a converter, then you implement iValue converter, just as you would in classic binding today. For one-way and two-way bindings, we listen to change notifications if it's a property and supports iNotify property changed, so its parent class implements that, or if it's a dependency property. So one of the pieces of infrastructure we've added in Windows 10 is a new API that you can register on an object dependency property pair for change notifications on any dependency property. It's not just limited to ones that you define. I can go register for the text block text or whatever, and that's basically how we do two-way binding as well. And if you're doing a index path binding, which is binding into the collection using square brackets, we will look for iNotify collection changed and or iObservable vector. And so if those five of your collection changes, we'll go and redo the bindings at that point. Two-way binding, the limitation there is that the property on the UI, I never know whether to call these the source or the target. Everyone gets very confused with that with binding. But the UI property needs to be a DP, a dependency property. We don't listen for events. We just use that same dependency property change notification mechanism to hook this up. The one exception that we've special cased is the text property on textbox, in which case, to keep the same kind of behavior as before, we now listen to lost focus, and we wait for that to occur before we'll update the text property. Other than that, it's very, very similar to classic binding. So another place where it's really common to do data binding is inside a data template. With pages and user controls, we can use the type of the page or user control as the basis for our bindings. For a data template, we need to know what type of item is this data template going to be used with. And so what we've done is we've added a new attribute, x:"data type, on the root of the data template. You then specify that data type using the standard kind of XML namespace to code namespace mapping. So in this case, I have to do it on the right screen. It's model maps to, that's an XML namespace that maps to my code namespace of XBind sample model. I've just used iEmployee here. It doesn't have to be an interface. You can bind to any type you want. So employees have a name, so I can just now do the name property in here, and that's bound to the name of the employee. It's pretty common with data templates to want to put them inside of a resource dictionary so they can be used in multiple places in your application. If you do that, we need to have a place to go stick the code gen for that data template. And so there's some extra steps you need to do if you're using xbind inside of a data template inside of a resource dictionary. First change is you need to give it a class. In this case, I've called it my templates, just by adding an X-class definition to it. In code, you then need to create a partial class for that, and then in the constructor of that class, call into initialize component. If you forget to do this, what's going to happen is at runtime, it won't have actually loaded the resource, and you'll spend quite a while trying to figure why is my XAML blowing up at initialize component every time. And it's because you haven't necessarily loaded the resources if you don't hook this together. I'm speaking from experience of finding those problems. Final thing is we need to have that constructor called. So rather than loading the resource dictionary with a source as a file name, I need to just specify it as a class. So in this case, my templates, that will then cause the constructor to get called. That will cause an initialize component. That will load the resources and do all the hookup for us. So flipping back, let's take a look at some examples of data templates. Stop debugging. So what I have in this case is a series of different list scenarios. So I've got a list view with a data template in line. The only thing I need to have changed there from kind of classic binding is adding the X data type. You'll see this is where I've got my slide demo from. And I can then bind to the name property. Sorry. Can I zoom a bit? Yes. Is that better? OK. If I want to do a data template in line, I can. I just need to add the data type there. I can also refer to that's used down here. Just refer to that with a static resource as I would normally. Oops, static resource. I can then also do it to resources defined in a template file. So my template XAML looks almost exactly the same as always, just I've now got that X-class statement, and I'm now using xbind in here. My code behind for it, all I have is that partial class definition calling into initialize component. Running the app. List and templates, kind of all those list views hook together as you'd expect. When the collection changes, the bindings and things will update. One other thing to mention, I'll show you actually in code. Data templates are not just used in list scenarios. You can also use them as a content template. So in this case, I've got a button, and I've specified that content template to be the same template that I was using for the list views. And now for its content, I have an index path binding into the employees collection. So that is yielding an employee, and that's then being used as the content template for the control. So far what we've talked about is functionality that kind of brings us up to parity between xbind and what I can do in classic binding. But we wanted to go further than that. And so the first thing I want to talk about is xphase. So if you're developing applications for a tablet or something kind of slow like this guy, which is now turned off, I'll have to log in again. I'll show that in a second. Then for our list scenarios, what we do is we kind of create a window over a much larger surface. And so when you pan with touch, we're moving that surface. That happens kind of lower level at the decomp demanipulator level. And so what the application is responsible for is rendering the items onto that surface. You could kind of consider it like a conveyor belt in a window. It's got to put the items onto that conveyor belt fast enough that when it comes past the window and is visible, everything is there in the right place. However, if your machine is kind of slow, then as we recycle elements and take them from one off kind of from the end that's no longer used onto the end that is used, we need to be able to do that fast enough to keep up with the speed of panning. On low-end machines, we can't necessarily do that. And so in Windows 8.1, we introduced a feature called the container content changing event. This is an event on list view. You get called back for each item, and it allows you to progressively render your item templates. Really powerful feature, solves the user problem, but to do it, you have to write code. And that code generally precludes the use of data binding. So what we've done with xbind and added a new feature of xphase, this allows us to do it declaratively rather than implicitly through code. So what I've got here is a data template, a couple of text blocks in it. This is a smaller example of a larger demo I'll show in a minute. And what I want to do is prioritize what I show in order. So I want the display name to always show. So I've not given that a phase. I've left that as implicit, which makes it phase 0. Items in phase 0 automatically get bound or automatically shown. But showing the date is less important. If I'm panning fast, the file name is really what I care about. And so I can delay that. And so what I've done is I've specified with an additional attribute that is now going to be in phase 1. And what that means is that that field or that control will be hidden until the phase comes into play, and then its bindings will be updated. We hide it so that when we're recycling elements, we don't have stale data shown into the UI. This is probably best illustrated with an example. We switch to the camera. And I need to log in again. So this little beauty is a Toshiba Encore 2. It is a Bay Trail Atom device optimized for battery life rather than CPU performance. And so what I have here, if it's running, yes. Go away, come on, okay. What I have here is a list view with a bunch of pictures I've downloaded of cats. Each item has a couple of different text blocks in there and the image. And this is using classic binding, so if I pan fast, what you'll see is we quite quickly end up in a situation where it can't keep up, and we kind of end up in white. Not the best user experience. We can change that using xbind, and it's a little bit better. One would say, well, hang on, didn't you make xbind so much faster? Isn't that going to kind of solve all world hunger and world peace? It makes the binding part faster, but it doesn't make the setting the text faster. And that's the part that's actually really slow here. You would think setting text is actually pretty easy, but once you start handling all the international and everything else in text, it is a lot more work than you'd expect, and it's quite slow. So what I can then do is switch over to xbind and xphase, and if I pan in this example again, what you'll see is when I go fast, we end up just showing the first line of the item, which is its title, and then if we have time, we'll go and render the other pieces, so they progressively come in. Depending on how fast, I've got one item there, I can then sometimes slow down, I'll get 2, I'll get 3, and then the image is the final piece of that puzzle. So that's on a low-end Slate device. You can find the same kind of thing on phones. Skip that, do the live down. So xphase is what allows me to delay and progressively incrementally render that item template. Some guidance for this. Technically, there is no limit on how many phases you could use, but I recommend keeping it to a handful. If you do more than that, it's going to generally spend more work figuring out the phases than actually doing the work. We still fire the CCC event, so if you want, you can hook that up as well and do your own logic in addition to the binding work. And the CCC, if hooked up, it will fire the first for each phase. So you'll get called for phase 0, then for phase 1, then for phase 2, etc. The phase numbers used with XCOM phase don't need to be contiguous. I could have 1, 10, 1,000. But again, keep it to a handful. But it does mean that you can leave a gap for 1 or 2 if you need to do CCC work in between, for instance, between the particular phases. In terms of how many phases you need for your app, that's really going to come down to your app, what you're kind of binding to pixel density to kind of control amount of work is to render those different pieces. And so really what you're going to need to do is try it, get your hands on a slow device. The $60 phones are great for that kind of thing. And try it, profile it, use WPA, use the Windows profiling capabilities of Visual Studio to figure out what's actually taking time and optimize that. The other big feature we've added for XCOM bind, which is new, is the ability to bind events. I don't know why we haven't done this before. Traditionally with events, if I have a button here with a click method, a poke employee needs to be a method on my code behind. What we can now do with XCOM bind is instead I can put XCOM bind and then a binding expression and now bind to wherever that expression leads to. So whatever method that is inside my model, if it doesn't need to have any parameters, we'll bind to parameterless functions, or it needs to match the event signature. In this case, it's a button click, so it's sender and routed event args. Alternatively, you can also use a signature that has base types of the event. We can call that directly. So in this case, I've used object rather than routed event args. You can use whatever base or interface classes you need. A couple of limitations here. We don't support overloaded methods. Trying to figure out from a set of overloaded methods which is the right one for an event. We just say, hey, we're just going to look for poke. I just want one version of poke there. I can do this on all events, not just click. And if you're an MVVM developer, it can replace some of the instances and uses of iCommand and event-to-command behavior. I can use this on any event, so I don't necessarily need to use event-to-command. The one thing to consider is if you're using iCommand with buttons, that will look at the can execute to decide whether to enable or disable a button. You can just do that as a separate binding instead if you need that. We also don't have a command parameter, but we pass in the object, so you can use its tag or put other attached properties on there if you need data for that particular item for the event handler. So taking a quick switch over to my demo for this. Eight. So for my event bindings, what I have here is, actually show the code first. What I have is a standard kind of click with regular arguments, no arguments, base arguments. These are just methods on my page. It's not kind of so exciting that way. But I can then just bind to them using xbind as I'd expect. I'm not just limited to methods on my page. I can bind to any model property that I want, in this case, index path into a collection. Where this becomes particularly interesting and useful is in list scenarios. So in this case, I have my data template for iEmployee and my poke button here that's going to call a poke method that's defined on iEmployee. So if I run this guy, is that one? Yeah. Event binding. What we'll see is I've got a set of different employees. Some are individual contributors and some are managers. I think Brian is an individual, so it just says he's been poked, and it calls the implementation on iEmployee. I also have classes that are manager, also implements iEmployee. So in this case, Quentin is a manager, so it says employees of Quentin rather than just Quentin itself. And so that's two different poke methods depending on which item I'm binding to in the collection. I had to use poke because I was trying to figure out what other words to use, but they all kind of ended up being HR violations or a problem. So xbind we do via code generation. The initialization of bindings is going to be different from classic binding. What we've done is we've created a new event called loading. There was already loaded as an event, but loaded occurs after the initial measure and arrange pass has occurred. Loading occurs before that, and we use that as kind of the last best point to go and update our bindings without having to go and redo the measurement that would occur if I did it afterwards again. So implicitly, we'll call bindings.initialize as part of the loading event. If you have your own data and you can call it initialize yourself, initialize is guarded, so you can call it as many times as you want, and it'll only actually do the work once. Now, if I'm making asynchronous calls to the file system or pulling down data from the web, I can't guarantee that I'm going to get that data in time before that loading event occurs. So instead, what I can do is I can use a method off the bindings object, bindings property that we insert into your code, and that has a method that has the initialize, update, and stop tracking. If I call update, that will update all the bindings, including one-time bindings. So after you've downloaded your data, you can call update, and that will refresh all the bindings for that particular scope. If for some unknown reason you're doing a whole bunch of work, you're going to change a whole bunch of properties, and you don't want one-way and two-way bindings to update at that point, you kind of want to delay the binding work. You can call stop tracking on the bindings object. That will pause the tracking. And then when you're ready, call bindings.update again, and that will forcefully update all the bindings on your page. Another thing to consider is one-way binding is more expensive than one-time because we have to create listener objects and hook up to INPC, et cetera. If you know, say, for instance, you've got a user control that displays all the stuff for an employee. If you know the data isn't going to change for that employee, then what you could do is do one-time bindings all throughout that. And then if the data has changed, call bindings.update at that point and force all the bindings in that scope to update in one go. So sometimes that can be actually more efficient than having a whole bunch of change listeners listening and poking around, and every time your path changes, you can actually force your update in one particular place. Similarly for lists, if I was doing the app with the files, I'm pulling those off the file system. The file system doesn't change very, very much. It's unlikely that the name will change. It's more likely if something happens, an item is going to be deleted, item's going to be replaced. I'm going to need to replace more than one binding on that. If I do one-way binding and I'm listening to every property change and every item there, that's an awful lot of change listeners going on for something that isn't going to happen very frequently. So the other thing you could consider there is rather than firing granular changes for individual properties, fire a change for the item as a whole using iNotify collection changed, and then refresh. That will then force a refresh of that entire object. Not all the binding paths need to support change notifications. So if I've got a one-way binding, for every node in there, we will look to see whether it's a dependency property or implements iNotify property changed. If it does, great, we'll register. If we don't, it doesn't matter as long as one part does, and that's what you care about the listening. Final one is a little bit kind of complicated to explain. So we have the binding scopes. That's like our page, a user control, a data template. As we're processing this, what we do is we build up a graph of all the binding expressions, and then we process those as a whole. So in this case, I have two controls, one bound to a first name property, one bound to a last name property, and both share a long complex binding path. Then for the model, the manager prop, the reports OC, the index into that, those were shared and common between them. So we'll generate one function for each of those steps, and then it's only where things are divergent will you actually get extra code generated. So we're pretty efficient at sharing the binding expressions between multiple bindings within that same scope. So let's have a look at what we're doing under the hood with xbind. Wrong one. So if I go back and I change this just to be, say, hello world, and let's give it a name. And I build this guy. What we can now do is drill into the code that's generated for that. So we generate two files, a g.cs and a g.ics. G.I happens in the first phase of compilation. That's generally needed for IntelliSense and for your app to compile. The g.cs we then build in the second phase of compilation, and that relies on being able to pull the data that you created in the first phase, pull the data from the first phase and reflect over it. So in this case, it looks very similar to it did before. One change we've made for Windows 10 is we used to use just the connect method for hooking up events. We now use it for hooking up names. So previously we used to do inside of initialized component, there would be find names for each of your controls. We've changed that to using a connect and a connection ID because find name involves a tree walk. That's expensive in XAML. It's much faster to have the runtime call back into the code and say, hey, here's a text block, here's a slider, here's whatever. So that's kind of what's going on in the most basic case. Now, if I change this to being XColumn bind, and rebuild it. I just changed the name. Sorry. Don't. Yeah, no, I hate typing on stage during demos. That's why I'm not thinking. Okay. Now, yes. What we should now see when I expand this guy is we've got main page. We're generating quite a bit more stuff. So we've now got a property in your page. Let's find that guy. Bindings. That's the bindings object you can call initialize everything else off. That's a type of this interface. We then generate a class here that implements that interface. And this is where all the logic for XColumn bind occurs. So in this class, what we'll see is here's our initialize, our update, our stop tracking methods. We have a field for each control we're going to bind to. And then we have a series of update methods. So for each binding path node in that binding scope, we'll create an update method. So update underscore is for the root, and all I used was data in this case. So there's then an update data method. That in turn calls into some static setter functions we have to go and update the text property of that text block. So that's just for kind of the simple data case. If I make this a more complex binding expression, so we say make this model. And I'll be explicit one time. If we rebuild, what we should see is that the update data method goes away. Instead, we now have an update model method, and that'll in turn call into update model string pop with INPC. So it's walking those binding paths, generating appropriate methods. And you can actually go step into this code, set breakpoints as you need to. If I copy this and remove the name, rebuild, what we'll see is we should see no additional functions because we've got two bindings using that same method, so it's that same path, but now we have that final node that's calling into two setters, one for object 2, one for object 3. Those are our two text blocks. If I go change this guy to, say, be the int property instead. What we should now see over here is we still have our model. The model method now calls into its two children, one for the string property, one for the integer property. So kind of this pattern is what we do to build up the logic for all of your bindings. If I go change this from one time to one way, what we're now going to do is look to see, hey, does that class support iNotify property changed? It does. I've got one binding that is dependent on that. Let me generate some code for that. So what we'll now see is we've got some additional objects around, and we've got an additional class. This is the bindings tracking object. And this then has a property changed method. So what we've done here is we've created a separate class to listen to the event handlers. And the reason for that is because of the kind of weak ref event handler pattern in XAML. When you handle one of those events, what you're handing over is an object and a method, and so that will keep that, the model will keep that object alive. And so rather than having that object be something that's tied to the UI and going to keep the UI alive, what we've done is created a small little object that can listen to those change notifications, and that then has a weak reference back over to our binding object. So if we do get a leak, we're just leaking a very small object that's just there for kind of tracking rather than leaking all of your UI. And so in this guy, we have our property changed method that's doing a pretty standard kind of INPC lookup. If it's empty, it'll update that property. Otherwise, it'll go do a switch on which property name is used and call things respectively. It also has an update child listeners method, and this is what will actually go hook up that change detection. So there's nothing kind of really rocket science in the code that we're generating here. It's taking your binding expressions, parsing them, spitting out a bunch of code. The only thing we really needed from the framework was the dependency property changed capability. That we're using here. You can use that on your own. In theory, you could go, if you're a masochist, you could go write all this code by hand. There's nothing framework special or specific that we're doing here, but it's just much easier to have something go and generate that, particularly when you end up with long binding expressions where you need to listen for changes on every single node as it goes on. So, there are some differences between compiled binding and classic binding. We don't support relative source equals self or element name. The equivalent to nextbind is just to give those guys a name. That'll create a field. You can then bind to that field. Hey, presto, everything works. We don't support relative source is template parent for xbind expressions. Generally, in a control template, you want to use template binding anyway. The documentation says that template binding and classic binding with relative source or template parent are the same. It lies. They're not. Classic binding is a lot more expensive than template binding. So if you can use template binding, the cases where you would need to use other binding there, use classic binding. The only kind of cases there is if you need a converter or you need the binding to be other than one way. Finally, with classic binding, it relies on the source property or data context to be set. Compiled binding, we need that type information. That's not available there. So you can't dynamically change that point. Options are use a kind of a longer path to get to the data. We're quite efficient at dealing with those. Or alternatively, just add another property to your page, bind to that. We can bind to fields or properties as you need to. We've not deprecated classic binding. It's still there. We need it. There are cases that we can't handle in compiled binding. The classic binding is much better for. Duck typing is one. I thought the name just came from an architect, but apparently this is a common phrase. It comes from the basis of if it walks like a duck, quacks like a duck, tastes like a duck, then treat it as a duck. And so what that means for classic binding is I could have a person object and a wine object, two completely independent objects, no base class or interface or anything between them. Both could have an age property. As far as classic binding is concerned, at runtime it's going to say, hey, do you have an age? Yeah, give me the value. Hey, do you have an age? Give me the value. And so it can work with those. With xbind, we need to know what type that is. Now, we do allow you to use a cast expression to specify a data type. But that's going to be a lot of work and isn't necessarily appropriate for all scenarios. In which case, continue to use classic binding. Dictionary graphs. Similarly, if I got a blob of JSON and I download it into like a Newtonsoft JSON object or whatever, we don't know from that, if I haven't serialized it into proper classes, what the types are. Classic binding works better if you want to kind of dot into those type of objects. Finally, we don't support programmatic binding creation. Everything has to be done at compile time. That you can still do with classic binding. One of the primary case, though, I've seen in our internal apps that have actually been using programmatic binding is primarily to get kind of the notifications of dependency properties. So now we have an easier way of doing that. So if that's what you're trying to do, just register for the change on that dependency property rather than creating a binding to get there. Yes. Oh, sorry. I didn't. Yes. Hang on, let me pull up an example. Click button, click button, click. I need to switch back over here. Other bindings. So there was a case in here I had. Okay, here's a good example. So in this case, I'm binding to the background property on the page. Background, that property is of type brush, or it's type brush, I think. But what I really want to get to is the color of the solid color brush. If I just left that as, if I actually remove this, let's see. Never do live edits. What I should get for that case is a compile error because it'll say, come on. Build. Ah, yes, invalid binding path. It can't find color off the brush. If I go back in here, what we can do is use kind of an attach property syntax, cast that to solid color brush, and then say, hey, I want to access the color property of it. This feature is actually available in classic binding. We found it through, it's vaguely documented. It's mentioned kind of in a side piece. Oh, you can do this for attached properties. Oh, and you can use it for cast. And we're like, oh. So it is there. It's a lot less needed in classic binding because invariably, unless the object is implementing separate interfaces and not exposing the functionality to that interface, you can normally find the property there. But with xbind, we need that kind of capability. So you can put a cast in there, and we'll process it that way. So that's kind of the functionality we've got in this release of xbind and XAML. It's a new feature this time. We've kind of come in hot. I'm sure when you try it, you'll find bugs. If so, please tell us. We'll endeavor to fix them. But there's further that we want to go than what we've implemented so far. So I'm not giving any promises, but if you see Joe Stegman or Tim Hewer, give them a kick and say, hey, can you do this feature, please? Seems to be much more weight played on customer requests than internal. But things we're thinking about in future, the ability to bind to a function. So I really don't like converters. They're kind of an ugly way of doing it. Allow me to bind to a function instead and specify the function parameters of other binding paths. We've kind of got prototypes of it. I think that one will end up doing. But it can also solve the multi-binding solution as well, because I can now bind to multiple expressions at the same time, timed together as a single function. Other things we've been thinking about, so for data templates, we kind of create this code behind class for it, but it's not really truly a code behind class that you as a developer can go play with for your data templates. So what we're looking at, we've been thinking at there is, how do I enable you to specify your own class for that data template and then have your own logic ties together with function binding, so I could then put functions in there and use those with inside the bindings of that data template. And then also, how could I then scope and access stuff from the data object, from my class, or larger scope? We don't have a solution for find ancestor with xbind so far. I think that would solve the most common cases for it. Something we're thinking about and looking at. Phasing right now is only supported in data templates. Kind of makes sense there, but if you step back a bit and say, hey, could I enable this for startup as well? And then how do we pass that phase kind of concept down the tree? So if we've got a user control inside of a data template right now, that user control can have one phase, but we don't enable kind of sub-phases with inside that user control to be defined and kind of bubble up. And then if I did do sub-phases, how do we make that work with the rest of kind of the phasing model? So there's some work to do there to think about it. But that's one of the other features we're looking at for Xbind. Finally, can we have a better solution for known object graphs like JSON or XML data? So, wrapping up, we've introduced a new form of binding in Windows 10, compiled binding. Generally replaces most of the functionality of classic binding and is faster and uses less memory. If you find bugs, please, or you've got feedback, send it to the Feedback Hub or talk to us here. In terms of extra sessions, there's another one today at 5 p.m. And then on Friday, really interesting, is a talk by Andrew and co. from the Office team on their use of XAML in Office. So the modern Office is actually built on top of XAML. They did some extra infrastructure work, but they're doing a talk on kind of how they've used XAML together with Office. The demo app that I was showing, that's just an early drop of the demo app that's in the SDK. That should have gone live at 2 p.m. today. So if you want to go play with phasing or whatever, download that sample and play with it. Thank you very much. I should say, fill out the evaluation form. It's really good for us. It's really good for the session planners. Thank you.